All right. Cool. Hello, everybody. Hope your week's going well. Just some reminders as we kind of close in on spring break. This is actually a turning point in the class. Oops, didn't even click there. This is sort of the last day that we're going to be talking about not project stuff. So starting next week, it's going to be all about the project. So this class is the topic that we're talking about today is kind of in a weird spot too, because it's not really part of any homework assignments, but it's also not directly tied to the project. It's just a useful skill to have. So with that in mind, it's a good time for me to talk about, well, for starters, I'll be honest with you and tell you I haven't graded a single thing since the last time I talked to you, but that's going to change hopefully today, this afternoon. I'm going to start picking up where I left off with the grading, which is on assignment 3. And then I also wanted to remind you all that while I'm not too worried about deadlines, I am very much worried about our shift to the project and would very much like to have all of the homework assignments done by the time we get back from spring break. So, if you need extra time on a homework assignment, that's fine. I still don't have a problem with that, but definitely would like to get all of those homework assignments resolved and taken care of so that we can just focus on the project for the class after we get back from spring break. So if you've already talked to me and given me a heads up about needing a few extra days on something or having to turn something in late, that's totally fine. If you haven't yet, give me a heads up. Let me know where you're at, just so that there aren't any surprises or anything like that. Cool. I think that'll do it for now. Let's go ahead and start talking about today's topic, which is debugging. I'm going to start by going over the very basics. So I imagine that most of you probably are already at least a little bit familiar with how to use the debugger, but I'm going to start there for sure with just the very basics, and then also go above and beyond, setting breakpoints and those simple kinds of concepts, and show you some advanced debugging techniques that hopefully will come in handy for you. The debugger is an intimidating tool, right? I remember my first interactions with it always kind of seemed pretty confusing, like how the heck do I drive this thing? What's actually going on right now? The best way to get over that is to just really force yourself to keep using it until it starts to click, until it starts to make sense in your brain. So getting some practice today, I think, will be good for you, especially if you don't have much debugging experience from past classes or past projects. I've set up a repository that we're going to use, and you're welcome to clone on your own machine and follow along, because everything that I'm going to be doing today is baked right into Eclipse, so you should have access to be able to do everything that I'm going to show you right along with me today if you would like to. So find this debug repo link on today's date on the calendar if you would like to follow along with me and clone it using the method of your choice. I'm just going to use Eclipse today to keep things simple. I'm planning to use the command line a bit later, but for now I'll just clone this repository in using Eclipse. Oh, okay, here's this error message again, just as a reminder, since this is one of the more common ones, just complaining that this folder already exists and has stuff in it, probably because I, used this the last time I taught the class. So you just need to give it a different name, tack a number on the end or something. Probably won't happen to you, but it does in the future. All right, here we go. So we've got this debug repository, and I'm going to start with example 1. I'm actually, all of these examples don't really do anything functional, right? They just have some sort of made-up code to allow us to show off various parts of the debugger. So if you're looking at these methods like, what the heck is actually going on here? Don't worry about it. It's just example code. It's just meant to be code for us to play around with. It's not actually doing anything useful. But we can still kind of talk about it in general terms so that we know what we're looking at when we debug. We can see that first we're calling a method called makeAthing that is going to give us some sort of an object, and then we're printing that object out. That's what the main method is telling us to do. But in order to understand these, we need to look at the method declarations and see exactly what's going on. We can see that here it's creating the object, printing it out, and then returning null. And then here we can see that after it calls print this, it's going to print it out here. Let's go ahead and run this code. See, we actually have an error. It's a null pointer exception. Right? It's a null pointer exception. This is actually one of the most common kinds of errors that you might run into. And the question here is, how do we figure out how to fix these kinds of errors? In a small program like this, it's very trivial to just go through and examine line by line and see and figure out where the problem is. You may have already raised some eyebrows at some of the lines of code that I talked about, earlier, like why is it doing that? Of course that's the problem. But imagine this is a bigger program where you've got lots of methods, lots of lines of code, and you do have some information with which to work off of. You can tell that from the error message down here that the error happened on line 8 in main, and on line 19 is where the actual null pointer exception originated from. But in order to understand how this error happened, we first need to understand what this error is actually telling us. So a null pointer exception happens when you try to call a method on an object that is null. It doesn't exist. It does not exist. So if you ever get something like this, a null pointer exception, first go to the line where it happened. It's telling you right here, just by looking at the error, that the null pointer exceptions happened right here on line 19. Look for any methods that are being called, and specifically look for any methods that are being called upon objects. I don't mean objects like in the generic sense. I mean any class, right? Any object type, right? These are the values that you should start be looking at and suspecting to be null. So the values to the left-hand side of the dot when we call the method, that's the object, object.method. So if you're getting a null pointer exception, it's telling you somewhere on the left-hand side of the dot, we've got an object you're trying to call method on, but that object is null. So you can't call a method on something that doesn't exist. That's the problem. But then the art of debugging, or really the question of debugging is, how did this get here? Because I don't see, at least just from what's on the screen right now, how this value of O could have gotten to be null. It was passed in as a parameter, right? So we really need to examine and see, work our way backwards through this code to try and figure out how this actually came to be null in the first place. And we're going to start by using our first debugging tool, which is to set a breakpoint. So this is actually something we talk about in the intro class, but just as a refresher, to refresh your memory. A breakpoint is simply a tool that we use to tell the debugger that we're interested in pausing the program at this point. We're interested in stopping here, and then just taking a peek around, looking around to see what the variables are, what's happening at that point in the code. You can actually have multiple breakpoints set, so you're not limited to just one. Although for a small program like this, probably one is plenty. But again, for a larger program, there might be multiple points of interest. So you can set breakpoints in multiple places, and it'll stop at whichever one it hits first. Whichever breakpoint it hits first is where it's going to ultimately stop and let you look around. In order to make sure that it does that, you have to run it in debug mode. So it actually requires the program to be compiled differently. Talk about that a little bit. We'll actually talk about that a little bit at the end of class today. So you have to start it in debug mode. And once you do, in Eclipse, it'll show you that it's paused here on line 6. And then the things to take a look at in the debugger that you don't normally get a view of when you're writing code and running code. On the right-hand side, we have the variables window. So this keeps track of all of the variables that are currently live in the code, as well as what their values are. Right now you can see there's not much of anything. We're on the first line of the program, so there's nothing's really happened yet. On the left-hand side, we see the stack trace. So this is keeping track of what methods have been called and the order that they've been called in. This is actually a very vital part of how these programs get executed. We'll see a little bit more about how that works in just a moment. So from here, we have a couple of different ways that we can control the debugger. We can drive the debugger. We're usually looking at this section of the IDE up here. So the red square is our stop button. That's pretty obvious. We just want to stop the program and start over again. We can click on that guy. The green resume button, or it might be called continue, says keep running. Just go. Right? I'm done looking around. You can continue on now. And it will keep running until it hits the next breakpoint. So if there's another breakpoint set somewhere else in the program, it'll stop again. If there's not, then it'll just keep running until the program is over. These arrows here are the ones that usually we're most interested in with the debugger. These are the ones that allow us to step through the code line by line. So the one that we usually introduce people to first is step over. Step over and step into are kind of complementary to each other. And it has to do with method calls. So if I click step over, it's going to stay in the current method. Step over is saying, essentially, step over any method calls that exist on this line and stay in the current method where you are. So if I click step over from this point, I'm going to go to line number 8. That would be where step over would take me, and I can actually show you that by go ahead and clicking that button, right? But if I stop the program and then restart it in debug mode to get us back to line 6, we can talk about step into. The step into button says if there's any method calls that are happening, I want to go into those methods and start stepping through those. So there is a method being called here. It's called make a thing. So if I click step into, I would expect to be taken to the first line of this method call, which is line number 12. So if we click step into, jumps us down to line number 12. So again, step over is used if you want to ignore any method calls, just stay in the current method and move to the next line in the very same method that you're currently in. Step into is used if you want to actually step into any method calls that are existing on that line and step through those methods. Now you do need to be a little bit careful about using step into. It's your choice, right? As the programmer, as the person driving the debugger, whether to choose step into or step over. And it's your decision to make based on whether you think the problem is inside of that method or not. Right? If you think the issue is inside of that method, you think the problem with the code that you're trying to fix might be inside of the method that's being called, then step into is the right choice. If you're confident that that method is solid, right, not the likely cause of the issue that you're trying to fix, then you can step over it. One other thing to keep in mind, which is kind of interesting, although not super useful, we don't write all of the methods that we use. There's actually lots of methods here that are being used, like print line. That's a method, right? But we didn't write that method. That's just given to us by Java, right? That everybody uses. But we can still step into that method. So if I move down to line 13 and then click step into, here I am inside of the print line method, which, while perhaps interesting, maybe, is not useful to us at all. We can't change it. We didn't write this code. We can't change it. Java wrote this code, right? Oracle wrote this code. We can't do anything with it. Also, this is not the problem. This code is not going to be the cause of the problem. So stepping into code that you didn't write, like these kinds of Java provided methods, is usually a waste of time at best, just going to confuse you at worst. If you ever find yourself in this situation, though, that brings us to the last of these 3 yellow arrows, and one of the ones that I think is talked about the least. Step return says, get me the heck out of this method and take me back to wherever I was before. Take me back to wherever method I was at originally. So where was I at originally? It's a good time to take a peek at the stack trace. Whenever a method returns, that word return quite literally means go back to where the method was called from. How does it know how to do that? The stack trace is keeping track of every method that gets called. So when this print line method is done, when it returns, when it's over, it's going to look at the stack trace and say, all right, I need to go back to line 13 in this file, in this method. And if you click step return, that's going to allow us to just basically finish up the rest of this method and go back to that point instead of stepping through the method. So step into takes us into a method, step return exits the method, step over skips the method entirely, just tells us to run the whole thing without examining the contents. And again, it's hard to tell which of those buttons you need to use. That's one of the most common questions that I get asked. It's like, how do I know step into, step over? Sometimes it's just you got to feel it out. You got to have that knowledge of the code that you're debugging to know where to look. Alrighty. So if we get back to the task at hand, right, which is to figure out why we got this null pointer exception, I have my breakpoint on line 6, and actually it'd be pretty simple to see, even with just a step over, that after that method returns, O is already null. So because I know I'm tracking down a null pointer exception, I can see that O is already null. That tells me that the problem must be actually in this method. So maybe restarting the debugger again and stepping into that method would eventually lead us to see that, oh, it's returning null here. That's why it's not doing that properly. What we probably intended was to return the object that was created, not null. Which brings me to an interesting point, a good rule of thumb. Returning null is almost always a bad idea. I know that I'm guilty of this, though, having null as the result. But it should definitely be avoided, along with its kind of sister situation of passing null in as a parameter to a method. Also, not usually a good idea. Again, I've done it. Probably will continue to do it. You can still make things work sometimes by passing in null when you don't happen to have whatever thing it's expecting in that moment in time. But it's bad practice, right? It's definitely better to have this thing. Do you have a question? Oh, okay. So step 1 is to set a breakpoint. So I've set mine on line 6, which I did by just double clicking over here till I see the blue circle. Or you can also right click and toggle breakpoint. And then once you see that blue circle there, make sure you're clicking the little bug at the top. If you click the green circle like you usually do, it'll ignore the breakpoints. It won't actually stop there. But if you click the little bug, it'll pause at this point. And now, is it just not showing up the box? So you have the stack trace, you just don't have this? All right, cool. For that situation, click on the window menu, go down to perspective, and then hit reset perspective. And see if that fixes your problem. Nice. Cool. All right. I'm going to move on to any other questions before I move on to the next one. To get out of debug mode, in Eclipse, you can actually click on the little J up here. That's what switches you back and forth between, the mode that you're probably used to writing code in versus the debugger, which has the stack trace and the variables window, which you probably don't need if you're just writing code, right? You only need that when you're debugging. That's why they give you the option to switch back and forth between the two. I'm going to go ahead and move on to the second example. Example number 2. So in this example, we're dealing with arrays, although again, like the previous example, this isn't doing anything actually useful or practical. It's just an example for us to play around with while we're doing debugging. First thing I'm going to do is try to run the code and see that I got an illegal argument exception. It's out of bounds, it's saying. Again, if we take a look at this, it's telling us where the problem happened. It's saying that it happened on this line. So this is where the exception came from. It actually originated here at this point in time. And so the the question is, do we know, what index happened to cause this situation? In other words, in a practical example, we'd probably have a loop going through and providing these accesses from 0 to index 100,000. And this error could happen at any point from 0 to 100,000, right? It could happen at any point in that array for any possible reason, perhaps. And so we need to have a way of figuring out exactly which point during that process the error is happening. But if we set a breakpoint in that situation, then we are going to end up looking at a lot of good situations that aren't causing errors before we're able to find the negative situation that is causing an error. And so what we can actually do to try and rectify this situation is to tell the debugger to stop once the error has been hit. So instead of using the debugger to go through and step through the code and try to figure out how that error is getting generated, we can actually tell the debugger to actually let us look at the program as the error is happening and see all of the variables and examine things at that point in time to get more useful information about the problem that we're trying to solve, instead of using a repetitive breakpoints. So the way to do that is to actually use what's called an exception breakpoint. So in Eclipse, we'll do that in the debugger mode by clicking on this breakpoints tab, which is over here. Oh, you can see all my breakpoints from all of the other code that I've been writing. And we want to set an exception breakpoint, which is, hold on a second. I am not in the right place. Breakpoints, set exception breakpoint. Well, I'm running into just an issue of my notes aren't being specific enough to tell me which menu to go into. And there are too many of them. So give me a second here while I figure this out. I might actually just Google it. Let's just Google it. Add Java exception breakpoint. That's what I'm looking for. Oh, yeah. Perfect. Okay. I think I figured it out. It's this guy right here. So I was close. On the breakpoints tab in the debugger, for starters, these are all the breakpoints that I have set in basically every program in Eclipse right now. But what I'm interested in is setting a breakpoint for a specific exception. So if I click on this button right here, it brings up a list of all of the different kinds of exceptions that can possibly exist. And to be clear, an exception is just an error, right? It's just an error that happens to cause the code to stop working. So I know I'm worried about an illegal argument exception. We can search for that. And now, whenever this exception gets thrown, instead of just crashing the program and coming to a screeching halt, we've actually set a breakpoint that's going to pause at that situation and allow us to look at the variables as this error is taking place. So let's start this up in debug mode now and see that as soon as that error gets thrown, we can pause, and if I switch back to my variables tab, I can see, okay, here's the index where the problem is. Again, this is not actual code. This is just sample code used for debugging purposes. The actual error here is just the classic off by one. Arrays of length x have a last index of x minus 1. The real thing I wanted to show you was the ability to pause your program upon an error and then examine the actual contents to see what the variables can tell you about that error that's being caused. It's a very useful technique. Contrast that with, what happens when usually you run code that has an error. This is what you're looking at, right? Which is still useful information, but this information taken in conjunction with the values of the variables at the time of the error can paint a clear picture about what's happening and like it's a problem. So while we're on the topic of exceptions, I actually want to take a little detour. This is not 100% directly related to debugging, but let's talk about exceptions for a second. This statement right here is one that I wouldn't expect many of you to have seen, perhaps. But what this is doing is throwing an exception, which in Java speak is just basically saying an error has happened. So usually we're on the receiving end of this. Usually the exception is caused by some mistake that we made as programmers, right? We went off the bounds of an array, there's an index that wasn't valid, something like that, or there was a null pointer somewhere, right? Usually the problems are due to us. But if we want to, we can actually check for our own situations that we know will cause errors, and then say, hey, this is a problem, this is an error. It's basically a warning flag to other programmers that, hey, you screwed up here. You caused a situation that is not valid. You need to take a look at the code you wrote and figure out what the problem is. So throwing an exception is quite literally the exact same thing as, if I tried to access something that's very clearly out of bounds, this will also throw an exception. I would need to do that sooner though, wouldn't I? What's my error? Oh, I see. So when an exception gets thrown like this, just like a generic index out of bounds exception, that is the same exact process that is happening when you say throw new illegal argument exception. And notice that the information that gets displayed is, this error message is quite literally taken directly from what you say here. So if you have useful information to provide about what happened here or why, that can be a good place to do that. Another kind of thing to be aware of with exceptions, there's actually two types of exceptions in Java. The types that I've shown you so far are called unchecked exceptions. So these are ones that we can't necessarily predict are going to happen. They're just due to goofs, due to programmers making mistakes, right? No programmer sets out to index an array improperly. It just happens because we're human and we make mistakes. So we can't predict those kinds of things. Those are just things that happen. We can catch them when they do happen and raise the red flag, be like, hey, you screwed up, go find the problem, go fix it. There are other exceptions that we can predict, or at least have relative surety are likely to occur, have a higher chance of occurring, and those are called checked exceptions. So checked exceptions in Java, one of the most common examples is anytime you're using files in Java, you're probably going to run into a checked exception. In fact, I'm going to code up a little example now. Using files, I'm going to blow this example away and make a new one. Right? Just making a brand new file that doesn't exist. And let's say I want to read that file using the file reader class. Have to import this as well. Okay. So this is a pretty standard way of reading the contents of a file. There are lots of other ways. In 131 we show you how to use scanner to read the contents of a file. I believe you could actually run into a similar situation using scanner. Maybe you have. File reader is just another tool similar to scanner that allows us to read the contents of a file. But if I look at the error message here, it's telling me there's an unhandled exception type, file not found exception. This is an example of a checked exception. This is basically saying that the Java thinks that the possibility of this happening is high enough that we need to be prepared for it. So it's telling us that the possibility of this file not being found on the computer is high enough that you need to have some kind of message to tell the person when that happens, when we can't find the file. We actually have two ways that we can deal with this. The way that, and Eclipse is showing us actually both of them. The one that people usually end up on is this one, try catch. So what a try catch statement is used for, anytime I'm doing something that might cause an error, that I suspect is possible to cause an error, I'm going to put that in the try block. And then if an error occurs, I will catch that error. And the code that is in the catch block specifies what to do when that error occurs. If the error doesn't occur, right? So if this line of code, or any other lines of code, this doesn't have to be just one line, I can do more stuff here too. Right? If any of these lines of code cause this specific error, right? It's not going to catch any exceptions. It's going to cause this specific error, the one where I can't find the file that it's trying to work with. If these all run without causing that problem, then we just skip over this whole block. We don't do it. But if any one of these lines causes that error, then we jump down here and we do this stuff, and the program stops, right? It's an exception. The program's over. So typically here, you can see printing the stack trace. That's actually something that we've been using already. That's this. When you see this happening, that's the result of printing the stack trace. The only other thing that I might actually consider doing in a catch block is printing out a message in English, right, as to what you think the problem is, right? So giving a human readable, and more information is always better if you can. This is a trivial example. I don't have a whole lot of information to give. But if you're able to give more information about the problem that occurred, anything that can help the person, staring at this problem to try and fix it, is what you should do inside of a catch block. So this is a pretty common approach to dealing with checked exceptions that Java is requiring you to deal with. If it makes you uncomfortable that you're being forced to deal with this, consider that whether that file exists or not is totally outside of the control of this code. Right? I could take this program and run it, even if this file, even if I made this correct, right, and pointed it at an actual file that exists on my computer, I could give you this code, and then that file is not going to exist on your computer, right? Or maybe the file does exist on your computer, but you move it, or you delete it, or I can't control those things. Those things are outside of the control of what I as a programmer can do. So Java is saying you have to be prepared for that. You have to be prepared for those situations. It happens often enough. The other thing that we can do with these exceptions, the other option is to add a throws declaration. So when an exception gets thrown, it travels through the entire stack trace. Travels through the entire stack trace. So think about all of the methods that get executed, right? Let's say I call 5 methods in a row and then I hit an error. That error is going to travel up through all 5 of those methods until it eventually hits the very first one, main, right? If any of those 5 methods at any point along the way catches that exception, that means that they know how to deal with it. They have a solution or at least something to do. But if they don't, they will continue to throw it all the way up, all the way up, all the way up. And if that exception gets thrown all the way up to main, and main also throws it, then that means your program is going to stop. And that's when you see the red text on your screen. It means that the exception was not caught, was not handled. The program needs to stop. And so, excuse me. This is actually, while an option to do, usually not the right option to do. You can see what Eclipse did when I selected it. It tacked this line on here. It's tempting. It's always tempting to choose this solution because it seems shorter and simpler to deal with. I don't have that big try catch block I have to worry about. Looks kind of scary. But this is quite literally passing the problem off to somebody else. So choosing this option is basically saying, yeah, I understand this problem could have happened, but I'm not going to deal with it. I'm going to throw it up the chain and let somebody else work about it, right? So not a very nice thing to do at the very least. Can you do it? Yeah, absolutely. The code allows you to. But best case scenario, you've got a problem that is going to go completely unaddressed and confuse the crap out of somebody. So you're not handling it properly. And worst case scenario, you could make somebody mad, right? Like, why are you throwing this problem at me? You should be doing this yourself. This is your situation to handle. So almost always I try to encourage people to do the try-catch approach when Eclipse suggests this. Notice though that it only does this for checked exceptions. Again, Eclipse will never ask you to write a try-catch statement for an array index out of bounds exception. That's an unchecked exception. It just happens due to goof ups, right? You don't have to worry about those. It's only in these specific situations. Connecting to the internet is another one, right? Anytime I'm writing code that has to connect to a network, well, I don't know if this computer is on the Wi-Fi network right now. I don't know if there's a firewall on this network right now. There's a whole bunch of things that are outside the control of the code, such that it's going to make you, prepare for those situations. What do you do if the internet's out? You got to provide some kind of an error, some kind of a warning in that situation. All right. Let's get back to debugging. I got a few more techniques that I would like to show you. I'm going to move on to example 3. Okay. Again, this is just another very simple derived example. There's not anything actually useful happening here, but you can see that unlike prior examples, we've got some randomness going on. So imagine for a second that we're running this program and we see, okay, I run it and I got a bad value at index 42, and that might be it might be a good clue for you to go look and say, all right, what's that value of 42? What's so bad about it? Why? What happened? But then let's run the program again. You can see, okay, this time I got a bad value at index 36, and if I run it again, 94, 24. So it's not consistent, right? These kinds of errors are really tricky to deal with. Really, really tricky to deal with. The kinds of errors that we prefer to deal with are the ones that are repeatable. Right? If I do X, then Y, then Z, I can see the error happen. So I got to figure out what's wrong with X, Y, or Z. But if it's changing, if the error is happening at different points, in different runs, then it's going to be trickier to figure out where the problem is. Trickier to figure out how this is happening. So in this particular case, you might be tempted to, start looking for things by setting a breakpoint, right? Something like this. But here's the issue. If I'm looking to see if everything's okay, right? Okay, it's checking the value for I equals 1, I equals 2, I equals 3. Well, I don't care about all of these values. I only care, again, about the values that happen, the values that exist when the problems are happening. That's the situation I want to see, so that I can try and figure out how the values got that way and fix whatever problems are occurring. If it's making its way through this loop and everything's fine, then trying to use the debugger like this is very clunky and awkward, right? I can sit here and click until I've detected that a problem can happen, but it would be better or more convenient for me if I could have the debugger just stop when it detects that a problem is occurring. And so what am I really looking for? I'm looking for a situation where what does a bad value consist of in this situation? It's if it's 0. So apparently it doesn't want 0 values. Okay. If the value in the array is 0, then that's going to be a problem for me, and I want to see what's going on with my code, with my program at that point in time. I'm going to click on the Expressions tab, which is up here next to the breakpoints and the Variables tab in the debug perspective in Eclipse. And if I click on one of these blank lines here in the Expressions window, I'm going to type in oh, actually, that's not what I meant to do. That's a different technique. This has actually created what's called a watch point or a watch value. This is another useful technique, but not the, sorry about that, I took the wrong turn. Not the one that I intended to, not the one that I was intending to use at this moment in time. Let me actually stop this. I intended to set a conditional breakpoint, is what I intended to do. So in order to set the conditional breakpoint, I might have to look this up again. Let's see. I am in example 3, line 11. Here we go. Yeah, I was on the wrong tab. Sorry about that. What I intended to do was to set a conditional breakpoint. And so in order to make a breakpoint conditional, locate the breakpoint in question in the Breakpoints tab, check the conditional box down here, and then enter what condition you want to use to trigger this breakpoint. I don't want to stop at this breakpoint every time. I only want to stop at this breakpoint when my array at I is equal to 0. That's the condition that I want to use to stop at this breakpoint. Okay. So if we start the debugger up again now, we'll see that it did in fact stop at this breakpoint, but if you look at the value of I, you can see that it's not 0, right? When the breakpoint was not conditional before, it just stopped at this breakpoint when I equals 0, I equals 1, I equals 2, every single value. But now we've told it to only stop when it detects 0 in the array at index I. We can actually use the expressions window. This is kind of what this is useful for, right? If there are any values that you want to keep track of as you're walking through the debugger, specific values. This is also called a watch list in a lot of debuggers. Yeah, these conditional breakpoints are extremely useful when working with trying to debug stuff inside of them, as well as in this situation, dealing with anything that is non-deterministic, that has a degree of randomness involved. It can be very useful. Alrighty. I've got one more technique to show you in Eclipse before we actually switch back over and talk about command line stuff. So let's talk about classes. Here I've provided a very basic class, represents a cat. And the interesting thing, one of the interesting things about classes is that they have instance variables. They have these instance variables. And so one useful thing that we can do to debug our classes, our objects, is to examine how these instance variables are used and how they change over time. And debuggers oftentimes provide a useful way to do this. Notice that if I click down on these lines of code, like in the constructor, I get breakpoints. But if I click on these up here, it looks a little bit different. So if I double click over here next to the instance variables, I don't get what looks like a breakpoint. If you hover over it, it actually says it's a watch point. It's a watch point. And so these watch points are set on instance variables. They're not targeting a line of code, they're targeting an instance variable. And the way they work is they come in two flavors. I think if you right click on them, you can actually go down to breakpoint properties. There's two different versions, access and modification, or basically reading versus writing. So this one says pause anytime this instance variable is read, anytime I look at that value. And this one says to pause anytime that instance variable is changed or modified. So if we set watch points on these and start up in debug mode, do I actually have a main method? Oh, I do, yeah. Here we go. Let me start that over again, just so we see. So I started this program up in debug mode, and we can see that it first pauses on line 8, because line 8 is modifying the name instance variable. There is no breakpoint on line 8. It paused there because I had a watch point on the name instance variable that says to pause anytime it's been read or modified. So it'll probably stop on line 9 for the same reasons. And if I click continue, it'll stop anytime, again, those values are changed or accessed for any reason. Why is this useful? If I am convinced or concerned that the problem is within a particular class, right, then examining how the instance variables of that class change over time will help me identify any issues with methods not interacting properly within a class, for example. Changing instance variables at the wrong times or in the wrong places, things like that. Cool. All right, I'm going to switch over and do command line stuff for the rest of the class. Does anybody have any questions about what we've done so far before I navigate away from Eclipse? So I'm actually going to use the same code that I have been using do it in the command line instead of Eclipse. And I want to show you that we can actually do command line debugging as well. Now, it's not going to be as fancy as what Eclipse provides. In fact, I mean, if you gave me the choice, I would choose debugging in Eclipse every time over debugging on the command line. It's just far more convenient, provides a lot more information than what the command line is able to provide to help us out with fixing problems. But again, remember that sometimes we're using the command line out of necessity because we don't have the ability to pull up big fancy applications. I'm not saying that you should be happy about having to debug programs on the command line, but sometimes it happens, and it's a good skill to have in your back pocket should you find yourself in that situation. So I want to show you how to do that. The first thing I need to do is cd to the directory that contains the code that we were just working with, and if you are following along with me, it's going to be in your, if you use Eclipse to do it, it's going to be in your home directory in a directory called git. If you didn't use Eclipse, it'll just be wherever you cloned it, presumably using the command line. Right? So I have a lot of repos in here, but here's the one I used today, debug repo 2. So I'm going to cd into that one. Whoops. Okay. I'm next going to cd into the source directory here. There we go. Now remember from our conversation, I don't remember when we actually talked about it, but it was maybe a week or two ago. The first thing I'm going to have to do is compile this code. It has to be compiled in a special way in order to be used with the debugger. And so we have to take the package into account. This is something that will probably come up again on the project. It's a common thing that trips students up when trying to compile these Java programs, is making sure we take the package into account. So from the src directory, I'm going to use the javac command. That's the Java compiler command. Let me zoom in so you can actually maybe read my screen a little better. Since I want to debug, I'm going to pass in the -g flag. And then we can tell it to compile the file. I'm going to do the cat file. If you want to know if it worked, you can take a look at the contents of the debug directory, and I should see there's now a cat.class file, right? Remember, those are the files that contain the ones and zeros that the computer actually wants. The Java code that we write is more for humans than for the computer, so the compiler takes that human stuff and converts it to the ones and zeros for the computer to run. That's a very high level description, but basically what's going on. So if I want to run this code, again, I'm still in the src directory, right? So I have not left that src directory. I'm going to run it, java debug.cat, where this is the package. If I have a package listed here in the top of the Java file, that package has to be included when I run the Java program. And you'll notice that it did run the program, but it didn't actually run it through the debugger. Just like we saw in Eclipse, if I want to run the program in the debugger, I have to run it a slightly different way. So to have it actually use the debugger, the way to run it is JDB, Java Debugger. And we'll use the same package and the same program name. All right. So here's what it looks like when I run that command. It's initializing the Java debugger, and now it's waiting. It's sitting here waiting for me to give it some instructions. So notice that I didn't set a breakpoint. That's a little tricky for me to do. I can't click on a line, right? That's not possible. So instead I have to tell it where I want it to stop. So I can say something like stop at debug.cat colon is what we use to separate for the line number, right? 30. So instead of setting a breakpoint, this is how we use the command line debugger. This is just going to tell it to proceed along. What is line 30 actually? That is, oh, that's the very first line, yeah. It's the very first line. At this point we can use the, oh, well, I thought we could, but I was getting ahead of myself. We have to tell it to start so I've set the breakpoint at line 30. I'm going to use the run command to tell it to run. And here we go. It's hit the breakpoint. It's trying to run the program, and it's hit the breakpoint. It's spit out a whole bunch of information about starting the VM, and it's telling us that it's hit the breakpoint in the main method, line 30, right where we told it to. It's even showing us the line of code that it's currently paused at. And so from here, we have a few different things we can do. List shows us kind of a little area around where we currently are, just a little view of the code from where we currently are, so that we can see the lines that are coming up. And then from here, I can say step. And if I don't specify what kind of step, it's going to default to step into. So I was on line 30, which is calling the cat constructor, and you can see that after I told it to step, it's now telling me I'm on line 7, which is the cat constructor. That's the beginning of the cat constructor. So if I want to step multiple lines, well, let's make sure I have multiple lines to step. Yeah. There it goes, setting the instance variables. Where am I at now? Okay, I'm on the last line of the constructor. And now I'm back in the main method. Here we go. And let's say I wanted to step through multiple lines. I can put a number out in front and say 3 step. And now if I take a look at, whoops, it only stepped me once. Why did it only step me once? Okay. Well, that's clearly not doing what I was hoping it would do. I was hoping it would step me 3 lines, but it didn't actually do it. And that's all right. To step over, it's called next. So step is step into. Step over is next. I wonder if, can I use a number with next? No, that did not work. Oh well. Anyhow. Type exit to leave the debugger and get back out of the, get back to the command line. It's definitely a little clunky to use. Again, not my first choice, but it is there. It is available if you need it. And one other thing to keep in mind is that while what I've showed you today is true for the Eclipse debugger, most debuggers come in similar flavors. So if Java's not your destination language, the Python debugger is also going to have step into, step over, all of those things, as well as C debugger and all those other languages. It's a pretty standard format. So once you learn how to drive one debugger, you can get pretty good at driving the other ones as well. Cool. So I wanted to wrap up today with an exercise. We've got 20 minutes left, and um, let me figure out where I put the exercise real quick. Debug. There it is. I believe it's a command line debugger. Yeah, debug example 1 via the command line. Just getting some more practice with this. The other thing that I wanted to offer up is homework advice slash help. I know some of you are still working on assignment 4, some of you are maybe working on assignment 5. I'd be happy to use this time to talk to you about homework stuff. But we got 20 minutes left, so